Hi, my name is Maria Acosta, and my major is in petroleum geology.
Hi, I'm Patricia Zamora, and I'm a geochemistry major.
Hi, my name is Cindy Lazo, and I'm a petroleum geology major.
Hi, my name is Jess Gonzalez, and I'm an environmental geology major.
The purpose of this project was to learn and identify tectonic activity, deformation, and mapping. Learning to identify geological outcrops helps us learn and document our own observations in all its aspects and data by hand in our fieldbook. Also, when learning in a lecture, often different concepts are taught when out in the field. In the field, we learn how structures relate to each other, as well as developing skills to look at the bigger picture.
Central Texas platform consists of the Texas Hill Country, the Llano Uplift, and the Edwards Plateau. The bedrock of the platform is made of primarily limestone. The Balcones fault zone extends through most of central Texas. The coastal plains bent downward due to the faulting of the Balcones fault zone, and the interior is still stable, and this stable interior is actually known as the Llano Uplift. The Edwards Plateau consists of 3 different stages. Stage 1 consists of limestone being deposited over carbonate rock, deposition of mud, marl, chalk, silt, and slate. Stage 2 consists of uplift of the carbonate rock and the thinning and pinching of new rocks and erosion. Stage 3 consists of increased uplift from the faulting of the Balcones fault zone. This exposes the older carbonate rock and begins the erosion of the Texas Hill Country. Since the Texas Hill Country is actually just it was formed by erosion, and in turn, this all formed part of the Texas Hill Country, which is known as the Llano Uplift. Inks Lake Park is located in Burnett, Texas, and on the east end of the Llano Uplift. Inks Lake is primarily made of gneiss with granite intrusions. Gneiss, which is a metamorphic rock, and the granite is igneous.
Since one of the reasons or purposes of visiting the Inks Lake State Park was to construct a topographic map, here in this slide it is showing a topographic map of the Inks Lake using its geological features. As the explanation indicates, the red color indicates igneous rocks, purple indicates metamorphic, and yellow represents sedimentary. However, in this case, there will be no sedimentary rocks shown. Also, adding to what we studied, we visited and explored and obviously hiked 10 sites within the park and made observations. For each station, we wrote down measure strikes and dips and just roughly studied the different geological features that we have learned throughout this course. In our geological notebook, we saw metamorphic contacts, dikes that were granitic in composition, as well as quartz in composition. There are also granitic intrusions, foliations, rectangular joining, folds, faults, and boudinage. Okay, so besides the topographic map, we also constructed a cross section from point A to point A prime, like shown in the map. This cross section shows the different geological features in the vertical plane through the Inks Lake State Park. It shows approximately the maximum elevation and the minimum elevation of the park based on the orientation we picked. In this case, the cross section starts roughly from the northwest to the southeast direction, with the starting elevation of 920 feet that goes down to 893 feet, and then gradually starts to rise up to approximately 1,000 feet. The cross section helps us geologists to understand what is under the Earth's surface and see what is happening or what took place like million years ago.
I'm going to be explaining some of the structures that we found in the park. The picture on the left is a boudinage. The structure is formed by extension. The rock is stretched and deformed until it forms sausage-shaped boudins. This particular picture shows granitic material in the inner boudin partition, which is the pinched section of the structure. This pinch is an area of low pressure where melt congregates, since all melt moves from high to low pressure. The picture on the right is square jointing. Most rivers develop some type of drainage pattern depending on the geology of the land. This structure is indicative of rectangular drainage patterns. Rectangular drainage patterns happen when the rock underneath is very resistant to erosion. In this case, the rock underneath is granite, which has been proven to erode very slowly. There were folds and dikes all over the park. Folds are indicative of deformation. In one of the stops on our map, there were folds and dikes present in the rock. Because some of the dikes were not folded with the other structures, it is safe to assume that they didn't all form together. The folds must have happened pre-deformation or during deformation, and the unaltered dikes must be after deformation.
During the trip, we examined geological features and structures which concluded in our maps and cross-section. A couple things we could improve on would be by having a better record keeping, also by assigning a task to each group member in order to have better results.